All right, we're doing 14C, which is simple interest and compound interest. Simple interest is called simple interest because it is basing the interest rate on a linear model. And the symbols that we're using, we have I for the amount of interest, P is the principal or the amount of money that you start with at the beginning of the loan, R is for interest rate, and N is the number of time periods. You do need to make sure that the units of your interest rate and your number of time periods is the same. So you can't have an interest rate, which is usually per year, and then have the time period in months, okay? They would need to both be in years for it to use the formula. And that's the same in the compound interest. You always have to make sure that your units of time, particularly, match. So the formula for simple interest is I is equal to PRN. And let's move on to compound interest. Compound interest is a little bit more realistic. Okay, so if you take out a loan, or let's say interest, let's say we're putting money in the bank, then once you earn a little bit of interest, that goes in the bank and you start earning interest on your interest. And the more frequently that your interest is compounded, the faster it will start to increase. So you get a bit of a curve happening, yes. So we use a lot of the same symbols. You'll notice that the formula has an A instead of an I. That's because the simple interest formula will only tell you the amount of interest that you've earned using that formula. Whereas in this formula, the A stands for the total amount at the end. It will add the interest onto your starting amount for that final one there. P is still your, we call it the principal or your starting amount of money. R is your interest rate and N is your number of time periods. Okay, so two formulas. Let's do some questions. A principal P is invested at 6% per annum simple interest. Simple interest. Okay, so if the principal is $4,000, how much money will there be after 8 years? The R is that 6% there. The 4,000 is the P, it's the amount of money. And 8 years, that is your N. So per annum is years and 8 years, so our time is fine. So our simple interest formula is I equals PRN. Subbing into that, principal was 4,000. The interest rate. Now, no matter which formula you use, you don't ever put a percentage into your formula. You always turn it, I usually turn it into a decimal because that will make things easier. You can do it as a fraction. So it would either be 6 over 100 if it was a fraction, but I prefer to do 0.06 because it's going to make things much easier for us when we do superannuation and loan repayments later on to have these decimals in here. So whatever percentage you have, turn it into a decimal straight away, please. And then the N is 8. Times that all together, you get, has anyone gone ahead? No? 1. That's right. Okay, the question says, if the principal is $4,000, how much money will there be at the end of 8 years? Have I answered the question? No. So it's actually, in a slightly sneaky way, asking me for the total amount that I will have at the end. So the total is simply the starting $4,000 plus the $1,920 that you've earned in interest. So we now have $5,920. Okay, on to part B. Find the principal, which is P, if the total at the end of 6 years is 8,500. Okay, so we're trying to find the P, so question mark on the P. We know that the total amount is 8,500. Ooh, that's interesting. The formula for simple interest doesn't have a total amount. It only has an I. That 8,500, I would need to subtract off a P whatever P happens to be, to know what that is for interest. Yes? The interest rate, we have to assume that this follows on because it's part B of this question here, so we're still going to be using the 6% or 0.06 as a decimal. And it tells me that N is equal to 6 years in the question here. Okay, so in our formula for I equals PRN using simple interest, the I is 8,500 minus P equals, still don't know P, so P is still there, times 0.06 times by 6. Okay, best thing to do would be to times these things together first. So 0.06 times 6 is 0.36 P. And then I want to collect the P's up. So this is negative P. Let's move that across the other side. So we will have 1.36P equals 8,500. And then all we need to do is divide by the 1.36. You get 6,250, right? And you could double check it if you wanted to. You could do 6,250 times 0.06 times 6, get the interest, add that on to your 6,250 again, and you should be back to 8,500 to make sure it works. Anyway, question 2. Imelda takes out a loan of $6,000 at a rate of 12% per annum, compounded monthly. Okay, as soon as I read that, alarm bells happen because my interest rate is per year and I'm compounding something monthly. Okay, however, whatever the compound rate is, so if it's monthly, yearly, whatever it is, that's what you need your interest rate to be in and your N. Okay, both of them. So 12% per annum, if you want that per month, there's 12 months in a year. So you go 12 divided by 12, that is 1% per month. Okay, continuing. She makes no repayments. Find the total amount that she owes after 5 years. So what we've got, you don't have to write these things down, but sometimes it's easier when you're starting out. There's $6,000 for the principal. We found out that our interest rate was 1% or 0.01. Our N, 5 years, wrong unit. I need it in months. So it'll be 60 months. So 5 times 12 is 60 months. Okay. Now also the words compounded is telling me that this is now switched to a compound interest formula. So compound interest is A equals P bracket 1 plus R to the power of N. Subbing in, we have 6,000, 1 plus 0.01 to the power of 60. While you guys are typing that in, we'll come back and see if we've answered the question. Find the total amount owing after 5 years, that will be this, and the interest alone. So I'm also going to have to find the interest once I have this number. What did we get? 10,000? Yes, 900.18. It's money. So the default for me is always 2 decimal places when it's money. Unless the question tells you otherwise, there will be some questions that will say round to the nearest dollar, that kind of thing. Okay, to get the interest, because that is the total amount, I need to subtract off the $6,000 that I started with. And that tells me that there's $4,900.18. That was interest. Part B. Find when the amount owing doubles to the nearest month. Okay. The funny thing is to do this, I'll do it one way first and I'll show you something else. I don't actually need to know what P is to know when it's going to double, but I do know P, so I can do it. I know that my principal is starting at $6,000. I also know my interest rate is still 0.01, so 1 plus 0.01. And I'm trying to find the number of months, which is N, that it takes for it to double. And for it to double over here would mean that it would go to $12,000. Now, before I solve it, since I mentioned it, if I did that same question and I didn't know what the starting amount was, 1.1 plus 0.01 to the power of n. The question doesn't have to tell you the principal. It did because it was flowing on from a previous part. But if it just said for the amount to double, I could put onto the left-hand side 2p, because that's doubled, and the p's will cancel off straight away, and then you'll still be able to solve it, even without knowing the p from the beginning. Okay, so keep that in mind, because it does come up in questions. All right, so the first thing I'm going to do is I'm going to divide the 6,000 across, and that gives me the 2 that we just saw from the other model. So 2 bracket, adding the bracket together, I get 1.01 to the power of n. To solve that, I'm going to have to slide the base. N will be equal to log base 1.01 of 2. And then you'll type that in. What did you get? 69.66, which means it says you round to the nearest month. So we'll say therefore 70 months is the nearest month. Question 3. An espresso machine bought for $15,000 on the 1st of January 2016 depreciates. And the word depreciates is in bold because that means that we have to modify our formula. In the compound interest formula, because our amount of money is increasing, in the bracket we had that plus sign. If something is depreciating, all you have to do is change that to a minus sign. So you could add this as an extra formula. P1 minus R to the power of n. So just changing the plus sign from compound interest, put the minus sign in there, and that means it's now going to be depreciating because you're subtracting off the part it's taking each time. Okay, what have we got? We have got a starting value, which is P, of $15,000. We have got an interest rate of 12.5%, which would be 0.125 as a decimal. And we are told to find how much value has been lost in 9 years. So n is equal to 9. All right, in that formula, A equals 15,000, 1 minus 0.125 to the power of 9. I got 4,509.87 cents. So it went from being worth 15,000 to 9 years later, it's now only worth $4.5 grand or a bit over. But the question says, find the depreciated value, done that part, and the loss of value over those 9 years. It wants to know in dollars how much money I've lost there. So the loss of value, to use their words, would be equal to the $15,000 that we started with minus what it's now worth, which means we've lost $10,490. That's been rounded, so that would be 0.13. But anyway, that was rounded to the nearest dollar. Okay, part B. During which year will the value drop below 10%? So using our depreciation formula, I could do this in two ways. I could do like I did with the twice the value one. I could just do a 10% of P, which I actually think is much easier for times less numbers together. So even though we know the value of P, how about we do it that way this time? So I'm going to leave the P in there, and I'm going to have 1 minus 0.125, trying to find that power of n that will make it worth 0.1 lots of P. Now the P would just be $6,000 if I wanted to put that in there, but they're just going to cancel out. And I will get 0.1 equals 1 minus 0.125 is 0.875 to the power of n. And now I can do a sliding base. Leave the n, log base 0.875 of 0.1. 17.24, is that right? You guys get that? So that means in the 18th year, but I could also say that as an actual year because we know we started in 2016. If we started in 2016, what should I do? 2016 plus 17 or plus 18 minus 1, which is 17. So you're adding on your 18, but it's always one less than that. So it's the year 2033. That's it.